High in the Peruvian Andes, at nearly 13,000 feet above sea level, sits Sacsayhuamán, a megalithic fortress featuring zigzag walls built from limestone blocks. Some of these blocks weigh over 200 tons, fitted together with such precision that a sheet of paper cannot slide between them. These are not ordinary stones stacked roughly. They are massive polygonal blocks with up to 12 angles each, precisely carved to interlock with multiple adjacent stones in three-dimensional puzzles. Modern stonemasons admit they could not replicate this work even with computer modeling and diamond-tipped power tools. But here is what makes Sacsayhuamán genuinely impossible. The largest stones were quarried from sites more than 20 miles away, requiring transport across rivers and up mountain slopes at extreme altitude and placement with millimeter precision. According to conventional accounts, the Inca accomplished this using bronze tools softer than the limestone, without wheels, without draft animals capable of pulling these weights, and without any construction records explaining the methods. New geological analysis, three-dimensional laser scanning, and comparative studies published in 2025 have finally solved the mystery of who really built Sacsayhuamán. And the answer is worse than we thought, because it exposes something deeply wrong with our timeline of Andean civilization. The evidence suggests the Inca did not build the megalithic portions of Sacsayhuamán at all. They inherited massive, precisely fitted walls from an earlier unknown culture and attempted to continue the construction using their own techniques, creating a site with two dramatically different quality levels that reveal knowledge loss rather than development. And the most disturbing discovery is this: the construction techniques used on the megalithic blocks do not match any known Andean culture. The weathering patterns suggest the stones are significantly older than the 15th century Inca attribution, and similar megalithic construction appears at multiple Peruvian sites across hundreds of miles, suggesting a sophisticated earlier civilization we have systematically failed to recognize. Let me show you exactly what the new analysis revealed. Sacsayhuamán sits on a hill overlooking Cusco, the ancient capital of the Inca Empire. The site consists of three massive zigzag walls built in parallel tiers, each approximately 1,000 feet long, plus various towers, gates, and ceremonial areas. The construction is attributed to the Inca Emperor Pachacuti, who ruled from 1438 to 1471 CE, though construction allegedly continued under his successors for decades afterward. Spanish chroniclers who documented the Inca Empire in the 1500s described Sacsayhuamán in awestruck terms that still resonate today. Pedro Sancho, secretary to Conquistador Francisco Pizarro, writing in 1534, called it a construction that appears impossible to describe, built of stones so large that no one who sees them can believe they were placed there by human hands. Garcilaso de la Vega, himself of Inca royal descent, writing in the early 1600s, stated that the construction was so amazing that those who have not seen it cannot imagine it, and those who have seen it cannot believe their eyes. The largest stones at Sacsayhuamán weigh an estimated 200 tons or more, the equivalent in weight to approximately 30 full-sized elephants or a fully loaded Boeing 757 aircraft. One particularly massive stone measures roughly 28 feet high, 16 feet wide, and 14 feet thick. These are not isolated examples. Dozens of stones weigh 100 tons or more, and hundreds weigh 50 tons or more throughout the three main terrace walls. Modern engineers looking at these weights immediately identify the challenge. Our largest mobile cranes can lift approximately 1,000 tons under optimal conditions, with careful positioning, stabilization, and counterweighting. But moving a 200-ton stone without modern equipment across rough terrain and up mountain slopes at an altitude of 13,000 feet, where oxygen levels are 40% lower than at sea level, presents extraordinary difficulties that strain the capabilities even of modern equipment. The conventional explanation involves log rollers, ropes made from plant fibers, and massive numbers of workers pulling together in coordinated effort. Experimental archaeology has demonstrated that this method can move large stones on relatively flat ground with sufficient labor. But Sacsayhuamán sits on a hillside with significant elevation changes. The quarries are located at various distances. Some stones came from sites over 20 miles away, across difficult terrain and including river crossings. In 2025, geological analysis precisely identified multiple quarry sources through trace element analysis of the limestone composition. Different stones came from different quarries at different distances, suggesting a complex, multi-source operation spanning years or decades. Some stones came from quarries less than 1 mile away on the same hillside. Others demonstrably came from sites 15 to 20 miles distant, requiring crossing valleys and rivers. Why transport some stones such enormous distances when closer sources of similar limestone existed? One possibility is that the distant quarries provided stone with specific characteristics, color, grain structure, and hardness desired for particular purposes. Perhaps nearby quarries were exhausted by earlier phases of construction, forcing later builders to seek more distant sources. Or possibly different construction phases used different quarries, suggesting the site was built over extended periods by different groups. The precision of stone fitting is where the real mystery deepens beyond mere transportation logistics. These are not simple rectangular blocks stacked in horizontal courses like conventional masonry. They are irregularly shaped polygonal blocks, many with 10 or 12 angles, each face precisely carved to mate perfectly with adjacent stones in complex three-dimensional arrangements. The joints between stones are measured in fractions of millimeters, so tight that you cannot insert a knife blade, let alone a sheet of paper. In 2025, three-dimensional laser scanning mapped the stone surfaces to sub-millimeter precision across entire wall sections, revealing something extraordinary. The contact surfaces between stones are curved in 3 dimensions, not flat planes. Creating matching three-dimensional curves on adjacent multi-ton stones requires either incredible precision in measurement and carving, or some technique for shaping the stones in place that we do not understand. Modern stonemasons attempting to replicate even small sections of Sacsayhuamán's walls report it would require computer modeling to calculate the matching curves between stones, laser guidance systems to achieve the precision during carving, and diamond-tipped power tools to efficiently carve the hard limestone. Doing this with bronze tools, which are comparatively soft and would tend to deform rather than cut dense limestone, seems physically impossible without extraordinary time investment. The conventional answer is patient handworking using harder stones as percussion and abrasion tools, pounding and grinding for hundreds or thousands of hours per stone. But achieving three-dimensional curved surfaces that match precisely across multiple stones through percussion and abrasion strains credibility. One miscalculation, one asymmetric error in carving the curve, and the stone will not fit, requiring either starting over with a new stone or accepting visible gaps that compromise the structure. Yet Sacsayhuamán's megalithic stones show no visible gaps, no obvious mistakes requiring correction, no stones that were carved incorrectly and abandoned as failures. This suggests either extraordinary skill and quality control with near-zero error rates, or techniques beyond simple stone-on-stone percussion that we have not identified. The weathering analysis from the 2025 studies revealed something unexpected that challenges conventional chronology. Different parts of Sacsayhuamán show dramatically different weathering characteristics. The massive polygonal blocks forming the lower foundations show weathering patterns suggesting significantly longer exposure to the elements than the smaller, more regular stones in upper courses. Limestone weathering rates can be calculated based on surface dissolution from rainfall, biological colonization by lichens and microorganisms, and mineral alteration from temperature cycling. The megalithic stones show weathering characteristics suggesting 1,000 to 2,000 years of exposure, potentially much older than the 15th century Inca construction date. The upper courses show weathering consistent with 500 years, matching the Inca timeline and Spanish colonial records. This pattern suggests two distinct construction phases separated by significant time. Older megalithic foundations, built by unknown earlier builders, and later Inca additions built atop existing walls using different techniques. This is not a new hypothesis. Researchers have suggested dual construction phases for decades, but the 2025 weathering data provides quantitative support based on measurable physical processes. The quality variation across Sacsayhuamán is striking and demands explanation beyond simple skill differences between workers. The massive lower walls feature the 100-plus ton polygonal blocks with seemingly impossible precision and three-dimensional curve matching. The middle courses show competent stonework with smaller stones, 5 to 20 tons, and slightly less precise fitting, but still impressive by any standard. The upper courses, demonstrably Inca work based on construction style and dating evidence, show much cruder construction with visible mortar, irregular gaps between stones, and less sophisticated fitting techniques. This is backwards from expected cultural development and skill progression. Technical skills should improve with practice and accumulated knowledge. Later work should show refinement of earlier techniques as lessons are learned and methods perfected. Instead, Sacsayhuamán shows declining quality over time, suggesting later builders attempted to continue or repair work they could not fully replicate, maintaining what existed but unable to match the original construction quality. The Spanish chronicles provide a crucial clue that is often dismissed but deserves serious consideration. When Garcilaso de la Vega interviewed Inca elders in the late 1500s about who built Sacsayhuamán's greatest walls, they told him that the most impressive stonework was done by earlier peoples, before the Inca Empire. They described them as builders of the First Age, or they attributed the work to the god Viracocha and his servants. The Inca said they merely continued or completed work begun by these predecessors. Spanish writers generally dismissed these claims as mythology or religious attribution, crediting gods or legendary figures rather than acknowledging human achievement. But what if the Inca were accurately describing their own history? What if they inherited partially completed megalithic structures from predecessors and added their own construction atop and around them using the techniques they possessed? The 2025 comparative analysis examined other Peruvian megalithic sites, including Ollantaytambo, Cusco's stone walls, Pisac, Machu Picchu, and others, looking for consistent patterns that might reveal construction authorship. The findings are remarkably consistent across sites. The most sophisticated megalithic work appears in foundations and core structures, with later additions showing progressively cruder techniques and smaller stones. At Ollantaytambo, 6 50-ton monoliths at the Temple of the Sun show the same impossible precision and similar weathering patterns, suggesting ages that exceed conventional Inca chronology. At Cusco, the famous 12-angled stone and surrounding walls reveal the megalithic technique in the lower courses, with clearly different Inca additions above. At Machu Picchu, the most precisely fitted stones appear in the foundations, with later, less precise work in upper structures. This pattern appears too consistently across sites separated by significant distances to be coincidence or random variation. Either the Inca developed extraordinary megalithic skills at the very beginning of their empire and then lost them within a generation or two, which makes no developmental sense, or they inherited megalithic structures from predecessors and never fully mastered the techniques. They maintained and added to what existed, but were unable to match the original quality. The toolmark analysis from 2025 examined carved surfaces microscopically, looking for characteristic patterns that reveal tools and techniques. The megalithic stones show unusual tool marks, linear grooves and patterns that do not clearly match expected stone-on-stone percussion or bronze tool working. Some surfaces appear almost polished, with remarkable smoothness and no visible tool marks at all. Some researchers have proposed the Inca, or their predecessors, used harder materials than currently recognized, possibly jade or other extremely hard stones, fashioned into specialized cutting or grinding tools. Others suggest unknown techniques, like stone softening using plant extracts. Local legends speak of plants that could make stone soft like clay, allowing shaping before rehardening. But no chemical evidence for such techniques has been found, despite tests of stone surfaces for organic residues or mineral alterations consistent with chemical treatment. The seismic engineering of Sacsayhuamán adds another layer of sophistication. Peru sits in an active earthquake zone along the Pacific Ring of Fire, yet Sacsayhuamán's walls have survived countless earthquakes over centuries without catastrophic collapse. The polygonal interlocking construction creates flexibility. During seismic shaking, stones can shift slightly relative to each other without catastrophic failure, then settle back into position using gravity and the interlocking geometry. Modern earthquake engineering recognizes this as a sophisticated design principle. Creating it deliberately requires understanding of seismic forces, structural dynamics, and how interlocking geometries dissipate energy. Did the builders, whether Inca or predecessors, understand these principles intellectually, or did they achieve earthquake resistance through trial and error, aesthetic choices that happened to be seismically sound, or inherited design principles whose original rationale was forgotten? The astronomical alignments at Sacsayhuamán provide additional clues about the builder's knowledge systems. Various walls and structures align with solstice, sunrise, and sunset positions, with certain star rising positions on specific dates, and with other astronomical events. These alignments suggest astronomical knowledge and deliberate planning that incorporates celestial observations into architecture. The Inca are known to have had sophisticated astronomical knowledge. They tracked solar and lunar cycles for agricultural and ritual calendars, used astronomy for navigation and timekeeping, and incorporated astronomical alignments in their architecture. So, astronomical alignments at Sacsayhuamán do not necessarily indicate earlier builders. But, if the megalithic foundations predate the Inca, as weathering evidence suggests, it indicates earlier Andean peoples also possessed substantial astronomical knowledge and considered celestial alignments important in monumental architecture. The dating evidence is frustratingly limited by the nature of stone construction. Radiocarbon dating requires organic material, such as wood, charcoal, bones, or plant remains. Stone itself cannot be radiocarbon dated. Dating at Sacsayhuamán comes from associated organic materials in construction contexts: charcoal from fires, plant remains in mortar, and organic materials buried beneath or between stones, which consistently give 15th century dates matching the Inca period. But these dates reflect when organic activity occurred at the site, not when stones were carved or walls were built. If the Inca were modifying or building around existing megalithic structures, the radiocarbon dates would reflect Inca activity, while missing the original construction entirely. It is like dating a medieval cathedral by radiocarbon dating wooden scaffolding used during 20th century restoration. You would get recent dates that do not reflect original construction. The 2025 studies attempted optically stimulated luminescence, OSL, dating on sediments trapped in joints between stones, hoping to date when stones were placed by measuring when sediment was last exposed to sunlight. The preliminary results are intriguing but inconclusive. Some joints show dates significantly older than the Inca period, but OSL dating has uncertainties and complications, and the results need replication and validation before being considered definitive. The construction logistics present another impossible challenge beyond mere stone moving. Moving and placing 200-ton stones requires not just brute force, but precise control during positioning. You need to maneuver the stone horizontally and vertically, position it within millimeters of its final location while it is suspended or partially supported, and set it down without damaging edges that create the tight joints. Any uncontrolled drop or shift would damage the stone and surrounding work. Modern construction uses hydraulic jacks with precise pressure controls, cranes with fine positioning adjustments, and engineered foundations to handle such weights safely. The conventional ancient method proposes earthen ramps that allow rolling or sliding stones into approximate positions, then precise levering using wooden beams to achieve final placement. But at Sacsayhuamán scale, ramps would need to be massive, potentially containing more earth and rock than the walls themselves, and requiring enormous labor just to build access infrastructure. Achieving millimeter precision through levering seems extraordinarily difficult. It requires sensing weight distribution across the stone, making micro adjustments to lever positions, and coordinating multiple workers. The 2025 engineering analysis calculated that positioning a 200-ton stone to millimeter precision using levers would require extraordinary skill and understanding, possible in principle, but representing master-level capability. The underground features at Sacsayhuamán add mystery to the visible surface structures. Beneath the visible walls are chambers, passages, and possibly additional structures largely unexplored. Ground-penetrating radar surveys conducted in 2025 revealed subsurface features suggesting extensive construction below current excavation levels, possibly connected chambers, additional walls, or other structures. If the megalithic walls continue underground or connect to subsurface structures, it implies an even larger construction scale than what is visible above ground. Why build extensively underground at such high altitude, where excavating rock through solid limestone would be extraordinarily difficult? Underground chambers could serve storage, defensive, ritual, or other purposes, but the effort required to create them suggests they held significant importance. The broader pattern across Peru is what makes the Sacsayhuamán mystery so significant for understanding Andean prehistory. Megalithic construction appears at numerous sites across hundreds of miles, from Sacsayhuamán and Cusco in the south, to Ollantaytambo and Machu Picchu in the Sacred Valley, and to other sites throughout the Andes spanning different valleys and elevations. All show similar characteristics, including massive, precisely fitted stones and foundations, later cruder additions, weathering patterns that suggest greater age than conventional chronology, and similar construction techniques using polygonal interlocking. This pattern suggests not isolated achievements by individual rulers or sites, but a widespread building tradition. Either the Inca developed these capabilities and deployed them across their empire, then lost them within decades, or an earlier Andean culture with these capabilities left structures across the region that the Inca inherited, revered, and built upon using the techniques they possessed. The lack of a clear developmental sequence supports the inheritance hypothesis. We do not see megalithic construction getting progressively more sophisticated through time. It appears in relatively complete and refined form in the earliest identifiable phases, then declines in later work. This is the opposite of expected cultural development, where techniques improve through accumulated experience and innovation. The Spanish conquest provides a natural endpoint for construction. After 1532, when Spanish forces conquered the Inca Empire, construction at Sacsayhuamán and similar sites ceased. The Spanish dismantled much of the smaller stonework to build colonial Cusco's churches and buildings, but they left the massive megalithic blocks because the blocks were too large to move economically. What we see today at Sacsayhuamán is primarily the megalithic core that was too difficult to dismantle, with some later Inca additions that were not removed. The 2025 analysis synthesizes multiple independent lines of evidence pointing in the same direction. Geological sourcing showing distant quarries for some stones. Weathering studies suggesting ages that exceed the conventional timeline. Variations in quality indicating multiple builders with different capabilities. Tool mark analysis showing unexplained characteristics. Engineering calculations demonstrating extreme difficulty with available Inca period technology. Comparative studies showing consistent patterns across multiple sites. and Spanish chronicles recording Inca oral traditions that claim inheritance of earlier work. The accumulated evidence increasingly supports a controversial conclusion that challenges conventional Peruvian prehistory. The megalithic portions of Sacsayhuamán were not built by the Inca, but by an earlier, sophisticated Andean culture whose identity remains uncertain. The Inca inherited these structures, built upon them using their own less sophisticated techniques, and maintained them as sacred sites, which is exactly what their oral traditions claimed to Spanish chroniclers. Who were these earlier builders? We do not know with certainty, because they left no written records and limited archaeological traces beyond the stone structures themselves. Candidates include earlier Andean cultures like Tiwanaku, flourishing 500 to 1000 CE near Lake Titicaca, or Wari, 600 to 1000 CE in central Peru, whose own sites show sophisticated stonework, though not quite matching Sacsayhuamán's scale, or possibly even earlier peoples whose names are completely lost, but whose stone constructions survive as their only legacy. The conventional resistance to this interpretation centers primarily on dating evidence. Radiocarbon dates consistently show Inca period activity at these sites, but radiocarbon dating measures organic material associated with construction activity, not the stone construction itself. If this interpretation is correct, archaeological methods have been dating the wrong thing, dating Inca modifications, maintenance, and additions, while systematically missing original construction by unknown earlier builders, possibly centuries or millennia earlier. The implications for Andean prehistory are profound and unsettling for established narratives. If megalithic construction predates the Inca significantly, it pushes sophisticated Andean civilization much earlier than conventional timelines acknowledge. It also implies knowledge loss. Later Andeans, including the Inca, could not fully replicate earlier capabilities, suggesting cultural disruption, population collapse, or other factors that broke transmission of technical knowledge between generations. The conclusion is uncomfortable. We have systematically misattributed one of South America's greatest architectural achievements for centuries. The most impressive megalithic work at Sacsayhuamán probably was not Inca at all, despite centuries of academic and popular literature crediting them. For too long, scholars have ignored or dismissed Inca oral histories that claim the Inca inherited earlier builders' work, treating those accounts as mythology rather than accurate historical memory preserved through generations. This matters profoundly because it affects our fundamental understanding of cultural development in the Americas. If sophisticated architectural and engineering capabilities appeared earlier than recognized and were partially lost, American cultural evolution was more complex than simple linear progress narratives allow. It suggests cycles of rise and decline, knowledge gained and lost, rather than steady progression toward complexity. What do you think? Sacsayhuamán's megalithic walls exist as undeniable physical evidence. 200-ton stones, fitted with millimeter precision, form three-dimensional puzzles that require capabilities challenging to explain. The conventional Inca attribution faces mounting challenges from multiple lines of evidence: weathering patterns that suggest significantly greater age, construction quality that declines rather than improves over time, Spanish chronicles recording Inca oral traditions claiming inheritance of the work from earlier peoples, tool capabilities that appear insufficient for the precision achieved, and transportation logistics that strain credibility at these weights, distances, and altitudes. The evidence from 2025, including geological sourcing, sub-millimeter three-dimensional scans, weathering analysis, and tool mark forensics, points increasingly toward earlier builders whose specific identity remains unknown, whose construction techniques we cannot replicate with certainty, and whose achievements we have systematically credited to the wrong culture for 5 centuries. The mystery is not just how Sacsayhuamán was built, it is who actually built the megalithic portions when they really built them. and why we have resisted acknowledging the evidence suggesting the Inca were telling literal truth about inheriting structures they revered as sacred, but could not fully reproduce themselves.